climate change impacts snow in a number of ways, and we have really good evidence that this is already happening. One way to think about this is that climate change projections from both, observations and models of the future both give us a lot of clarity that temperatures are warming. They have warmed so far, and they are expected to continue to do so. Precipitation is much less certain. We generally see indications of increasing precipitation in the Pacific Northwest, but there's a lot of intermodal disagreement between the climate models of the future, so that's much less certain. When we think about what that means for water, the big clear thing that we get from increasing temperatures is decreasing snow. And we talked about what snowfall equivalent is. So we see evidence of decreasing snowfall equivalent as a fraction of total precipitation. The data we have on this indicates that throughout most of the Western US, we have already seen statistically significant observable changes in, actually these have looked at April 1 snow water equivalent because that's where we have the longest record going back. And there we're seeing both decreases in the total amount of snow we get and generally advances in when it melts. So it tends to melt earlier in the year, which results in earlier runoff timing in our rivers and streams. So that decreasing total snowpack and advancing melt timing, we have great evidence that both of those are already happening, and our climate projections are consistent in saying that we can expect both of those trends to continue. A few other sort of interesting climate change impacts on snow that we see. One is, I told you we're getting earlier melt. That also tends to mean actually slower melt, which is a little counterintuitive, but it happens because when we think about the full energy balance that affects snowpack, when you get snow that melts really late in the year, maybe it's melting in May, in some places even June, July, there is a ton of sunshine coming in. And often it's that sunshine or solar radiation that's really melting the snow more than the temperatures. So if you have snow melting later in the year, when there's a lot of solar radiation, it can melt pretty quickly. Where if it's melting much earlier in the year, maybe in March, there's much less solar radiation coming in, and therefore your snow might actually melt more slowly, even though it's melting earlier. Another sort of interesting finding about how climate change is affecting snow is in terms of rain on snow events. So it's tempting to think that, of course, as we get more rain rather than snow, we'll have more rain on snow events. And in some places that's true. The sort of other side of that coin is that there are other places in the Western US where we had less snow to begin with. And if you decrease the amount of snow you're getting, there's no snow on the ground. So therefore you can't have rain on snow events. So there can be a dynamic where the amount of rain on snow events actually gets decreased in some places because you have to have snow to begin with. I think of climate change as being important in mountainous environments because mountainous environments are really important to us and to our environment and economies and ways of life. So there are a few sort of major things I think about when I think about why climate change is important in mountainous environments. That change in snowpack is really high level important because so much of our water comes from snow. When we get that warming, there's a threshold dynamic where we switch from snow to rain dominated precipitation, and that can have really big influences on our water resources. And of course, the water that falls in the mountains runs off downstream and then is important for small communities and then also for major cities. Right now, if you think about not just the Pacific Northwest, but the Western US more generally, the Colorado River Basin is seeing massive hydrological problems that are at least part, it incorporates plains and mountain hydrology, but the mountain snow hydrology is certainly affecting how much water ends up in the Colorado River, where we're seeing calls for major cuts to water use. Another really important component of climate change in the mountains is fire. So as we see increasing fire frequency and severity, that affects, of course, our mountain ecosystems. It affects water and hydrology. And then I'm sure you've all experienced that smoke can impact quality of life throughout the Western US and even throughout the US. We've seen smoke impacts on air quality. Mountains tend to have pretty unique biodiversity. So thinking about climate change and altering that environment, like the biodiversity is adapted to historical climate. So we'll certainly be affected by warming. I think recreation is important. And we could think about that in terms of recreation economies, like for hiking, skiing, fishing, hunting, whatever it is that you do. We could assign a dollar value to that, and people certainly do. But I also think it's important to recognize the quality of life issues. Like people love doing that. It's important to a lot of us. So I don't know that we have a great handle all the time on how climate change impacts recreation, but I think that's important for economic and sort of social, cultural reasons. Last one I'll add is forest products. I think, like, of course, in the Pacific Northwest, this is a major issue. And like, how much do our forests grow? At how much risk are they of burning down? That is, of course, a serious economic issue for people who produce and people who rely on forest products and timber. So locally, the two that stand out the most to me are the impacts on snow and how that affects water availability and timing, and then increasing fire frequency and severity. To me, those are the two that have the biggest likelihood of transforming our mountain ecosystems and then consequences for people and ecosystems who don't live in or maybe never even visit mountainous regions. Globally, I think those changes in snow and water availability and timing and fire, those are concerns in lots of places globally. But I think to really say, like, what are the biggest concerns globally for mountain regions, we'd really need to think about and hear from experts from and on global regions. I think a problem science sometimes has is not being aware enough or integrating global perspectives as well as we should, and assuming that we're qualified to, and by we, I mean American or Western scientists are qualified to speak about the rest of the world with perhaps more authority than we should. Yeah, effectiveness is an interesting question where I think we could probably stand to do a lot more research on how effective different adaptation and mitigation methods are. In terms of adaptation, we could think about this in terms of like the snow and water impacts that I talked about, as well as the fire impacts. So adaptation, I think there is a fair amount we can do in thinking about, realistically, a lot of our water resources go through dammed reservoirs, and reservoir operators are the experts on these systems and have engineering rules essentially that they use to operate them. So often that means at certain times of year, they are facing different restrictions on how much space needs to be preserved for flood control versus how much water can be stored in a reservoir. And so an example of an adaptation that might be useful is reconsidering what those reservoir rule curves look like and whether they can be adapted to the current water years conditions. One promising area there is forecast informed reservoir operations, where we can use better observations of our mountain snowpack and our incoming atmospheric rivers to better understand how much water those reservoir operators should expect to be coming through their system. So that's an area where we have people with tons of expertise operating these systems and new science coming online that might support those operations that gives me some optimism about adaptation. And then in terms of adaptation to fires, I'm less qualified to speak in as much detail on this, but there are a lot of smart people thinking about how do we manage our forests for increasing fire risk? How can we better listen to the people and include people who have been managing fire in these forests for thousands of years and incorporate sort of indigenous forest management practices, and think about, I think, where we live when it comes to fire and how we protect homes that are in places that are at increased risk of fire. We saw that really dramatically in Colorado this year, where homes burned that I don't think anybody really thought were at risk of wildfire on New Year's. So it's really thinking about how we adapt to increasing fire on our landscapes is a major issue to think about. In terms of mitigation, the really fundamental thing to, I think about is how can we reduce the amount of carbon that we are putting into our atmosphere? And we can think about that in terms of mountain regions, but also really big picture, we need to reduce the amount of fossil fuels that we're burning. There's nothing that we're going to do in terms of mitigation in mountain regions, especially, that's going to sidestep the issue of how much fossil fuel are we burning. So it's good to think creatively about mitigation options and everything we can do. And we also have to reduce the amount of fossil fuels that we burn. So a few things about mountain regions. One to think about is forest carbon sequestration. So how can we manage our forests and our soils to enhance sequestration to help them not burn down catastrophically? There have been a lot of challenges in terms of carbon credits. If I may tell a story, California implemented a payment for carbon credit system on forest lands, which was an interesting experiment and has sort of highlighted some of the challenges with payment for carbon services. There was a report that came out last year that showed, so as background, they had divided California into regions, and the way you got paid for carbon sequestration on forest lands was to store more carbon on your land than was the average for the region that it was in. In California, the coast is full of redwoods that have some of the most biomass and carbon sequestration of maybe any ecosystem. And then the interior Central Valley region is historically like oak woodlands that have they store some carbon, but not nearly as much as the coast region. And there was a interesting discovery that many of these carbon sequestration plots were located technically in the oak woodland region, but happened to be little plots of redwoods that were technically like on the side of the line on the map that was defined as the sort of open oak woodland. So the point is there was no real carbon sequestration happening. And so we need to be really careful about payment for carbon sequestration. That's become pretty clear. The other sort of thing I'll say about mitigation of climate change in our mountain regions is that, I mentioned hydropower has been environmentally contentious for a long time. It is also a really important part of a decarbonizing electrical grid. So as we get more wind and solar resources online, it becomes really useful to have renewable energy or low carbon emissions energy that we can turn on when we need to. So often that's called dispatchability. And hydropower is one of the most rapidly dispatchable resources that we have when it comes to renewable energy. So, of course, you all know that hydropower is not without its environmental problems, but it is also very useful for decarbonizing our grid. So it's a complex topic. Yeah, the most important thing I think to keep in mind, big picture about climate change, is that every gigaton of carbon that we don't emit, or every 10th of a degree of warming that we can avoid, is important, and it's important to do what we can to accomplish that. So sometimes we see summaries of IPCC reports that might say, in the media version, we have 12 years to stop climate change, imply that there is one fixed threshold. And if we don't cross that, we're fine. And if we do, we're doomed. And neither of those is true. It's a continuum, it's a spectrum where every degree of warming that we can avoid is valuable. And related to that, I would say to take the problem really seriously. I think there's a lot of value to working on the problem, and at the same time, not to fall prey to doomerism, because characterizing this problem as a doomsday one, I don't think inspires hope or a feeling that we can do anything about it. And it's not true. Like, it is a big, serious problem that we are already facing, and there is a lot that we can do to improve it. There's a lot of smart and caring and conscientious people who are working on trying to address the problem. And there are a lot of great career roles that I think can take care of you and your like personal and professional needs really well and contribute to working on climate change. So good luck. Just a little professional crying is good for the students to see.